Okay, example 2 is going to be a rational function where I actually have a fraction, and we're going to find the critical points of that. So step 1 is going to be exactly the same. Step 1 is going to be to take the derivative. Now in this case, I'm going to make an annotation to myself, because in order to take the derivative of this, I look and see, okay, this is a fraction, that means I need to use the quotient rule. Alright, so I'm going to separate this as 4x squared, that's the top, and the bottom, and I take the derivative of those two parts separately. Let's see, the 4x squared is going to become an 8x, and the x squared minus 1 is going to become a 2x, and that minus 1 is a constant. So when I put these together, let's actually write my derivative off to the side over here. We have to go in this order, 8x times x squared minus 1 minus 4x squared times 2x. And remember that when we do the quotient rule, we always have to put that over the v value squared. So this is my derivative. That was the very first step, and notice how I actually had to use my quotient rule here. Now the second step is going to be, same as above, set this equal to 0. But before I do that, I'm getting ahead of myself because we got a lot of cleaning up to do here, don't we? Let's take a side step right here, and let's just clean this up by doing some distributive property before we have to set this equal to 0 to see if we can simplify this. Let's just distribute here. We're going to get 8x times x squared, which is going to be 8x to the third. 8x times negative 1 is negative 8x. And before I subtract here, let's just multiply these two things. So it's going to be minus, let's see, the product of these two things is going to be 4 times 2 is 8. 8x to the third again. All over x squared minus 1 squared. Now if I do this, you can actually see that I have an 8x to the third here and minus an 8x to the third here. Those are going to cancel out. So this whole thing is just going to give me negative 8x over x squared minus 1 squared. So now I can actually set this, step 2, and set this equal to 0. Now when I set this equal to 0, we're actually going to do two things differently. Since this is a rational function, we're going to set the top equal to 0 and the bottom equal to 0 separately, not at the same time, because that would give us a whole, which is not a critical point. So let's just say, instead of saying set equal to 0, let's make this set numerator equal to 0. So let's take that numerator. I'll put an orange star next to this so that we know what we're doing. And we're going to take that numerator and set that equal to 0. This should be an easy solution, because if I divide by negative 8, 0 divided by anything is 0. So one of our critical points is 0. And that's because the numerator was equal to 0. So this is going to be a max or a min. This is going to be a horizontal tangent again. Okay. Now the other thing that I have to do is step 3 is I'm going to have to set denominator equal to 0. Now why I have to do this separately is because this is going to give us an undefined derivative. Alright, and remember from up above, a critical point can come from the derivative being equal to 0, which is what we had right here, or the derivative can come from that function being undefined. And remember that whenever we get 0 in the denominator of a fraction, it's going to be undefined. So let's just look at the denominator of that fraction. What would make this equal to 0? So let's just set that denominator equal to 0. X squared minus 1 squared equals 0, and in this case we really just have to set the inside of the parentheses equal to 0, because if 0 squared, well, that's going to be 0. So if I add 1 and then take the square root, I get x equals plus or minus, let's see, what's the square root of 1? Just 1. So this would be more critical points. These would be more critical points, but here's the exception to this rule. It would also be undefined in our original equation here. So if it's undefined in the original equation, it doesn't count as a critical point. It has to be defined in the original, which means it should be able to work in the original and get us a regular number, but not work in the derivative. And you see here it doesn't work in the derivative, and it doesn't work in the original function. So in that case, it's actually not a critical point. So these actually won't count. and this is going to be my only answer here. X equals 0, and that's where the derivative is going to be 0, which tells us once again that's a horizontal tangent, a maximum or minimum.